Hi everyone, in today's video we are going to be discussing the properties of a rhombus. First, let's review the properties of a parallelogram. In a parallelogram, opposite sides are parallel. Opposite sides are also congruent, meaning they have the exact same length. Opposite angles are also congruent. They have the exact same angle measure. Adjacent angles, angles that are next to each other, are supplementary, meaning that they add to 180 degrees. And finally, diagonals bisect each other. And remember, the word bisect means two congruent parts. Now, a rhombus has all the properties of a parallelogram. So those 5 properties that we just discussed also apply to a parallelogram. In a rhombus, all sides are congruent. So every side length of a rhombus is the same. The diagonals are perpendicular. Meaning that they form 90-degree angles. And finally, the diagonals are angle bisectors. Remember, a bisector creates two congruent parts. Let's look at an example problem. So number 1, if ABCD is a parallelogram, show that it is also a rhombus. And the property we'll be using is, in a rhombus, all sides are congruent. So I can take any side length and equal it to the other side since all the sides are congruent. So for example, we'll take 3x minus 11 and equal that to x plus 13. Remember, all sides are congruent. So we'll solve for x. X is equal to 12. Now, if we just want to verify that we did this correct, I'll also take the x plus 13 and I'll equal it to 2x plus 1. X would be equal to 12 here as well. And then finally, if I did it one last time, if I set 3x minus 11 equal to 2x plus 1. Notice that each time I do this, I get x is equal to 12. Now we want to verify this by substituting 12 into each side. So we want to do 12 plus 13. 12 plus 13, it gives you 25. 2 times 12 is 24. 24 plus 1 is 25. Then we have 3 times 12 minus 11 also gives us 25, thus proving it is a rhombus. Let's look at the next problem. In rhombus CDEF, diagonal FD is drawn and measure of angle E is 40 degrees. What is the measure of angle CFD? So let's see where CFD is. CFD is right here, so we'll put in X. So the property that we'll be using is, in a rhombus, all sides are congruent. So let's mark them using the congruence marking. And diagonals are angle bisectors. So if you notice here, I have a triangle, specifically an isosceles triangle, meaning if I make this y and this y, those base angles are congruent. And remember, angles in a triangle add up to 180 degrees. So I'm going to add y plus y plus 40 is equal to 180 degrees. Now, y is going to be equal to 70 degrees. I'm going to label y as 70. Now remember, diagonals are angle bisectors, so if this is 70, this also has to be 70 degrees. So the measure of angle CFD is 70 degrees. Another reason why I know this is I have two parallel lines, and this can act as my transversal, so I technically have a Z here. So if this is 70, this also has to be 70. Those are alternate interior angles. In the next question, in diagram below, MATH, math, is a rhombus with diagonals AH and MT. If the measure of angle HAM is 12, what is the measure of angle AMT? So here's AMT. I'll put an X there. Now, the property we will be using is, in a rhombus, diagonals are perpendicular. Remember, anytime you see the word perpendicular, I want you to think of a 90-degree angle. So notice here I have a triangle. And remember, angles in a triangle add up to 180 degrees. So I have x plus 12 plus 90 is equal to 180 degrees. 12 plus 90 is 102. 180 minus 102 is 78. So the measure of angle AMT is equal to 78 degrees. Always remember, diagonals are perpendicular in a rhombus. And last, in the diagram below of rhombus ABCD, the diagonals AC and BD intersect at E. If AC is 18, so this whole length here is 18, and BD is 24, what is the length of one side of a rhombus ABCD? Now remember, because all the sides are congruent, we just need to find any side of the rhombus. Now please remember that the properties that you're going to be applying to this question is diagonals are bisected, meaning they create two congruent parts, and they're also perpendicular, meaning they create 90-degree angles. So I'm going to put in my 90-degree angles. Now that they create two congruent parts, I have to take AC, and I want two congruent parts here and here. Now all I have to do is divide that by 2. 18 divided by 2 is 9. So therefore this is 9 and this is 9. Do the same thing for BD, which is 24. 24 divided by 2 is 12. So here's 12 and here's 12. Now notice that I have many 90-degree angles, which makes a triangle. So for example, I have a triangle like this, where this is 12, this is a 90-degree angle, and this is 9, and I'm looking for the hypotenuse because that's across from the 90-degree angle, which is really the side of a rhombus. Here, I can use Pythagorean theorem. A squared plus b squared is equal to c squared. I'm finding my c squared because that's the hypotenuse. So all I have to do is do 9 squared plus 12 squared. 9 squared is 81. 12 squared is 144 is equal to c squared. 81 plus 144 is 225 is equal to c squared. Now remember that I need to take the square root of both sides, and radical 225, if you put that in your calculator, it's a perfect square, and it's 15. So the side of this rhombus is 15.